Hey everybody, Jason from Alphatone Audio. Today I want to talk about power supplies. Specifically, I want to talk about two of the terms you hear all the time on power supplies, one being regulated and the other one being isolated. And we're going to talk about what those actually mean for your setup. And I want to go through a couple scenarios where you may run up against a brick wall with your power supplies and how to get around that to make them even more helpful for you. So first of all, I'm going to start with this one, but coincidentally, I'm going to start with the term isolated. Let's just say right off the bat, these are both regulated and isolated, and all the concepts I want to talk about in this video pretty much generically apply to any of these higher end power supplies. You don't have to go to the video lab. I personally just tend to like them, and they've done well by me for a long time. So first thing, when we talk about isolated, what does isolated actually mean? Well, from an electrical standpoint, when you say that a circuit is isolated, it basically means that it's literally isolated from other circuits within a particular device. The best way to talk about it or demonstrate what isolated really means is to start with something that's not isolated. So if you have something like this, your one spot, which is pretty common, and then you get the little pigtail adapter that goes on there, and it gives you 5 outputs on here. This is a good example of something that is not isolated. So if I take a multimeter, I just do a simple continuity test, you can hear the beat. If I just put this on one of the shields here, you can see it's going to hit continuity with every other shield. And even if I go on the center pin, if I go into the center pins of all these other ones, continuity, 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 and so on. It's basically just a wire with different insert points on it, okay? Not isolated, everything is together. Now, if you're running something like this and it works for you, by all means, just keep using it. There's no reason to go out and upgrade to an isolated, regulated power supply if you don't have any problems with your current power schemes. However, if you are running something like this and you do have hum, buzzes, or any other kind of ground loop type artifacts, then you may want to consider moving up to an isolated type power supply. So, and again, this cable was just this, nothing fancy. So, if we do the same thing, and we have the isolated power supply, if you start to do your continuity tests, you're going to notice that there is nothing. You're not going to get continuity. And I'm always careful when you do the continuity test on an active circuit. I always make sure to go both ways because maybe current only goes one way, not the other. You're not going to get continuity on any of this. And again, on the pins, you get nothing. And even if I swap again, you get nothing. Okay, every single output is isolated from every other output. So when you go to hook these up, very common, this gets power from this, and this gets power to this, nice and simple. So that's basically what isolated means. Now, first scenario you might have with a power supply like this is, let's say you finally go out and you spend a bunch of money and you get something like this. You think, man, 8 outputs. I'm never going to have more than 8 pedals until you buy your 9th pedal, and then you're stuck. So where are you going to get that 9th output from? Well, on these particular supplies, you can get this Y cable, which is a current splitter, which means it's basically just going to take one output and it's going to turn into 2 outputs at the same voltage. Okay, so how this works is basically just take this, one cable goes into one and one cable goes into the other. Now if you just do this, there's a little bit of a problem with the way these are right now. You can see that this pedal here on the right is not turning on and the one on the left does. And it's not the problem where you need to have the input jack in because it's still not going to work. The thing about the splitter is they're still keeping with the theme of having everything isolated by taking 1/2 of the splitter, and you can see there's a white stripe on one of these, and that is ground lifted. So once again, go back to the multimeter, and if I just start with the normal one, and let's just do the tip to tip, I get a beep, and shield to shield, I get a beep. Once again, back to the tip, I'm going to go over to going with the stripe, and now I get nothing. no center, I will get the shield on it. Oops, I will get the shield, but there's no continuity going through the center negative pin. So if that's the case, then how do you make sure that both of these are actually going to provide power to your pedals? What it's going to rely on, if I plug these back in one more time, is you have to make sure that the two pedals that you're plugging into each end of the splitter are connected. And you can tell as soon as I just touch this shield to this jack here, on the second pedal, it's going to power up. And there's our power, which basically means that the shield is going through here, probably going through the chassis to the output jack, flowing through to this pedal and going back to the power supply that way. What that's actually doing is it's only providing one path to ground as opposed to two. That's what causes the ground loops and the hums and the buzzes and all the stuff you don't want. When I was looking at this, I saw tons and tons of questions on the internet and different forums. It's like, I don't understand, why doesn't this cable work, whatever. Now, for the most part, this isn't going to be a problem for you. However, there is one particular scenario where even this simple setup is going to create a problem for you. And that's particularly true if you're running a stereo rig or a wet dry or, you know, wet dry or something like that. Anytime you're actually splitting your signal somewhere. Okay, so if I hook it up this way, I'm going to take one of these pedals, I'm going to plug it into the input. I'm going to take another one and I'm going to plug it into the isolated output here. Okay, you can see both cables are still on. And again, this scenario here is, let's say you're running like a wet dry rig and you have a certain amount of dirt pedals up front, and then maybe that goes out to your dry amp, okay? And then you want to continue your signal, and that's going to go through a bunch of wet pedals, and maybe that goes to the effects loop of your wet amp, or you're just sending them straight out from your board, or however you want to split it. And it's usually common that you want to isolate, especially transform isolate one of those amps from the other, so again, you don't get ground loops through that part of your signal chain. Now, if I take, again, two pedals, one on each side of the split, and let me just check. This one, oh, sorry, I got a little tangled here. Right, here, once again, the overdrive pedal is on the ground lifted loop. So what's gonna happen as soon as I throw this lift switch over here on the box? It kills power to the overdrive pedal because we broke that continuity through this pedal into the other pedal on the other side of the split back to the power supply. So why am I saying this? Just one of those things, if you ever end up getting a more complicated rig, maybe you're running some kind of a switcher or a looper, or you're transformer isolating or lifting ground anywhere in your setup and use one of these Y cables, you could run in the situation where you hook it up and one of your pedals just won't power up. And it can be a little bit difficult to troubleshoot if you don't know exactly how these things are working. Not a big deal though. I think it's a very simple problem to get around. And the way you get around it is, if you do have to use one of these splitter cables, just make sure that the two cables that you're going to power off the splitter are as close together as possible. And I would really recommend they go right into one another if at all possible. Of course, if you're using a looper or a switcher or something like that, then they're possibly on their own loop. And it should be fine. All the shields within the looper or whatever should be connected. Of course, depending on the functions or the model of your particular looper, there may be some kind of ground isolation or transform isolation inside of it. Just one thing to be aware of. Just the easiest way to get around it is just make sure that these two pedals are close as possible and everything should work fine. So that was isolated. Let's take some time and talk about regulated. Regulated power supply is very simple. When I talk about regulated, what they're actually regulating is the voltage. And what it means is that the voltage is always going to remain common, or it's always going to remain the same, which may sound obvious, but not all power supplies work like this. In a regulated power supply, if it says 9 volt, you're always going to get 9 volts. And yeah, this just has switches on the back and you can change it from 9 to 12. If you change it to 12, then it's regulated to be 12 volt. In a non-regulated power supply, as the current draw increases, the voltage will actually drop. And as the current draw decreases, the voltage will actually go up. So why would that create a problem with some devices? Well, if the voltage range exceeds what the device is capable of, it can destroy it. And if it goes below what it needs to operate, then it just simply won't operate very well, or it won't work at all. So that's what regulated means, and it's particularly handy to have with digital devices. So how can you use regulated to help you out in getting your pedal board set up? Clean this a little bit. So let's say you go out and you buy a new pedal, something like this, which as far as pedals go has massive power requirements on it. So you look at the back and it says 9 to 12 volt VDC, which is volts DC, so that's 9 to 12 volts DC current at 4.5 watts. And you think, well, wait a minute, what's a watt? Everything I read about on pedals is in milliamps. For example, on the back of this one, 9 volts DC at 40 milliamps. Milliamps is what we're commonly used to seeing, which is the current. Watts is a measurement of power. This doesn't have watts on it, so how are we going to figure out if we can actually power this thing or not? We can look at the power supply that came with this unit, and it says 9 volts, 500 milliamps. Well, looking at these, I know most of these are 100, with the exception of this, these two line 6 outputs, which are 250, and then all 4 of these are 400 milliamps, which is not enough if this puts out 500. Now, just because this is rated at 500 doesn't necessarily mean this consumes 500. It could consume less. But how are we going to know for sure if we don't know what the actual current draw of the unit is? So one of the things you can do is, of course, just read the manual, check the website, something like that, if it's not written directly on the pedal, which it's not. So if you go to look at the website and you see what it says this. Stomp boxes can operate from a 5-watt power source using regulated supply, 9 to 12 volts DC maximum. And it goes on, and then it gives 2 different current draws, one at 9 and one at 12. So at 12, it's saying the current requirement is 380 milliamps of power up and 300 normal operation. At 9 volts DC, it's 500 milliamps of power up and 400 milliamps of normal operation. So if it has a large current surge that needs a power up, and then that current draw reduces once it's powered up and it's in normal operation, you can see why they stress having the regulated power supply, because they don't want the voltage to go outside of that 9 to 12 volt range that powers the unit. Now, one of the things that we can do here is we can actually, if we didn't have these numbers, is there a way that we could actually arrive at these numbers? And the answer is yes, and that's by using an Ohm's law calculator. So let's plug these numbers into an Ohm's law calculator and see how they come up. As I said, if you get into a situation where you're trying to find out how much current a pedal or any other device that you want to power is actually going to draw, and the manufacturer just doesn't tell you how much, if you have the voltage and the power, you can figure this out using an Ohm's law calculator. So if we say on the lower end of the acceptable voltage range, which is 9, and it gives us 4.5 for the power, what we're going to do is we're going to change amps to milliamps to give us a much more familiar value, and we calculate. We can see that at 9 volts, 4.5 watts, it's coming back with 500, which is exactly what they said the maximum current draw for the pedal was going to be at 9 volts. If I reset it and we do it again at 12, and again keeping 4.5 for the power, we'll switch to milliamps, we calculate again, it comes back at 375. Their quoted current draw was 380, but 5 milliamps, not that big a deal. And again, the reason we're doing this is just to make sure that we get that current value, to make sure that any individual output on our power supply is going to be able to power the device. As far as the resistance, these calculators, they always put some kind of token resistance value in here. It's not really going to be a big deal for our calculations. We can just assume an incredibly low or even like 0 resistance from the output of the power supply to the input of the pedal. So don't sweat the resistance value here. If it pops up with something, don't worry about it. So based on those numbers, it looks like we do have an option over here with the pedal power digital. If we run 12 VDC, even at power up, it only needs 380 milliamps and it drops down to 300, which is within the specifications of the device. So come over here and take a look at this. 12 volt, 400 milliamps should power this, no problem. However, there's one more thing we have to get around on this. And that's that the power jack on this is just a little bit different from your standard pedal. And that's that this is 2.5 millimeter on the inside as opposed to the standard 2.1. So if you take standard cable, which fits in here with no problem, and you try to plug it in here, it's not going to work because that center pin is 0.4 millimeters bigger and it just won't fit in the hole. Now, one of the reasons for that is, unlike most pedals, which are center negative, this happens to be center positive. Now, the thing about that is, as far as electronics go, this is actually a little more standard to have center positive. The reason guitar pedals ends up being center negative is because so many of them for the longest time could operate on either the DC input or a battery. They needed a way to switch the power between the different inputs depending on whatever you do. So the battery's in there, it's going to pull battery power, which would then get activated whenever you plug the plug in. Or if you were going to plug it or power it off the power supply, then it would disable the battery and it would enable power input from the power supply. And it would do that using shunting on the jack, or jack normally or something like that. And I did a video a couple months ago where I changed out the jack on a chorus pedal, and I talked a little bit about this jack normaling. So if that's something that interests you, go check out that video. But the way most of these things work is they don't put those normal connections or those shunts on the center pin. They put those on the barrel. So that's why most of the pedals end up putting the positive on the barrel and the negative on the pin on the inside. So yeah, as far as, and again, if you have something like this, it takes this much power, you're never going to power this thing off batteries. So if you look at it from the perspective of just plugging on a power supply full time, then center positive isn't so bad. All you need is an adapter cable, which Voodoo Lab makes, and this is really specific to these. This is standard 2.1 times 5.5 millimeters on this side to 2.5 millimeter by 5.5 millimeters on this side. And not only does it have the different size barrel on this side, but it also reverses the polarity of the current. So it's going to take the center negative and it's going to convert it to center positive. So having said all that, plug it in here, plug it in here, and everything turns on, no problem. All is good. However, we have one more option if you don't have something like this with the high current outputs on it. Over here, like I said, this one happens to have 250 milliamps and 250 milliamps over here at 9 volts. So if you go back to the specifications under 9 volts, it said it requires 500 milliamps of power up and 400 normal operation. So based on that, if there was a way we could combine these two outputs, then we could power the H9 off of this one. And it turns out there is, just like we had our current splitter earlier, they also make a current doubler, which is set up just the opposite of that, which means I have two barrels. They're going to go here and they're going to go here. And they have an output, which you plug the cable into. And again, we have to use our special cable, 2.1 into that end and the 2.5 into this end. And once again, pedal powers up, no problem. Now, going back to regulated for just a moment, you could say, well, hey, these run at 9. I could bump these up to 12 because this pedal functions at 12 volts, no problem. I'll unplug this really quickly. Because as I said, on the bottom, there's a bunch of switches, and what it typically does is it changes for each output, it changes it from 9 volts to 12 volts, and for 7 and 8 it turns on this sag feature where you can adjust the volume or whatever. However, again, if you read the Voodoo Lab manual, as I do, read all manuals because I'm a huge nerd and I like to know these things, what you'll see is that if you flip those switches on outputs 5 and 6, it actually deregulates those two outputs. And it actually changes the voltage range that it outputs from, on the low side, 12 volts to on the high side, 14 volts, which you absolutely don't want. Because while it may power up just fine, once that power consumption for this pedal drops, and that voltage goes up to 14 or somewhere between 12 and 14, it could cause damage to your pedal. So you can do this. It works just fine. Just make sure you don't get too happy with this and say, oh, well, just, more headroom's a good thing. Don't worry about it. Keep these at 9 volts. Feed 250 to 250, give it to 500. You're within specification. The unit works just fine. But this is one of those things. Check your manuals, because these kind of details, they'll kill your device. This also brings us to another point about isolated power supplies, which I talked about earlier. And if you had something like this, again, non-isolated, then something like this is not possible. Not only can you not run multiple voltages out of a non-isolated power supply, but you also cannot mix center negative and center positive polarity devices. That for sure is a good way to destroy your power supply. Now, again, it's not a problem with something like this because they have the adapter cables and all that, and maybe you can get an adapter cable with one of these passive devices, but I don't know, I haven't looked into it. But just another benefit to spending the extra money and getting the isolated power supplies. There's just a lot of good features, and it's a lot more flexible, and you just get a lot more life out of it. And there's a lot more devices you're going to be able to power successfully. So that's about it for this one. I hope that was a good overview of both regulated and isolated power supplies for you and how they can help you get your board together and get everything powered the way it needs to be. If you found this video helpful, I would certainly appreciate a like and a subscribe. And until next time, I will see you later.